Today's video, so makikita nyo ngayon, we are starting to discuss a first lesson in general physics. Although it's not math and it's science, but for the soonest, meron tayong i-discuss na computation sa subject na ito. So this taken by a STEM 12 students or depends sa offer ng different schools sa STEM. STEM stands for Science, Technology, Engineering, Mathematics. Alright? So, our first lesson is all about random and systematic error. I guess, sa mga nakakita ng aking post sa FB page, alam niyo na siguro. We have lesson outline. So, first, define random and systematic error. Next, differentiate random and systematic error. Next, illustrate an example of random and systematic error. So first, let us define first what is physics. In terms of physics, the branch of science concerned with the nature and properties of matter and energy. The subject matter of physics, distinguished from that of chemistry and biology, includes mechanics, heat, light, and other radiation, sound, electricity, magnetism, and the structure of atoms. So, ayan po. Yan yung karaniwan sa physics. Sa physics, sa inyong junior high, maraming na sa inyo. From sa mechanics, mechanical heat transfer, mga ganun pa. Alright? When we say errors, no matter how careful you are, there's always an error in the measurement. Halimbawa, sa isang art, gagawa kayo ng borderline. Hindi naman natin masasabi na pantay na 1 cm ang naging espasyo nyo from the particular paper na ginagawa nyo ng borderline. Hindi ba? Or for projection of lines sa drafting. Hindi nyo masasabi kung ang 5 cm na dapat yung pro-project sa kabila is na-project nyo ng tama. No matter how careful you are. Ganun po ang ibig sabihin. Error is not a mistake. It is a part of measuring process. So, natural yun. Diba? Unless kung talaga nagkamali ka. Pero dito is not a mistake. No? Hindi natin may iwasan. In science, measurement error is called experimental error or observational error. Why kaya? So, we have precision and accuracy are two ways that scientists think about error. It means accuracy refers to how close a measurement is to the true or expected value. Accuracy. Diba karaniwan may criteria kayo dyan. Inaano dyan yung pinaka-expectation. Yung accepted. Yung inaasahan. For following the instructions, diba karaniwan doon naka-include ang accuracy. Dito, it refers sa accepted value ng isang measurement. Precision refers to how close measurement of the same item are to each other. Yung kung malapit na. Yan doon yung gaano siya kalapit. No? Like halimbawa, kung ang refer ay 5 cm. 4.5 is already a precise measurement. Kasi malapit siya. Ganun. So, makikita niyo sa isang dartboards. We have 4 dartboards result. So, unahin muna natin ito. How can you describe it using accuracy and precision? I'll give you some examples. First, so, this is not accurate, not precise. Hindi siya malapit sa bullseye. Hindi rin sila pantay-pantay. Not accurate. Diba? Next, how about the second dartboard result? So, not accurate but precise. hindi sila accurate pero malapit sila sa pangalawang bilog, such as the red one. Magkakalapit sila. Next one. Accurate. Ito pala, sorry. Magkakadikit sila, malapit. Ito, accurate but not precise. Kung nakikita nyo. Kasi may pagkapantay-pantay sila, nakapaligid sila sa bullseye, pero hindi sila precise, hindi sila magkakalapit. I hope you all get my point. Next. The last one, accurate and precise. Bukod sa magkakalapit sila, nakapasok sila lahat sa bullseye. I hope you get my point. Precision and accuracy are two ways that scientists think about error. Precision is independent of accuracy. That means it is possible to be very precise but not very accurate. And it is also possible to be accurate without being precise. The best quality scientific observations are both accurate and precise. Two broad classes of observational errors. So we have random error and systematic error. So, let us first discuss the random error. When you say random error, it varies unpredictably from one measurement to another, while systematic error has the same value or proportion for every measurement. Random error are unavoidable but last around the true value. The main reason for random error are limitations of instruments, environmental factors, and slight variation in procedure. Kaya nagkakaroon ng random error kasi maring kulang sa measure instruments o environmental factors like such as environment and slight variation in procedure. Mahirap ang pagsasagawa. We have examples of random error. So first, when weighting yourself on the scale, you position yourself slightly differently each time. Alright? Minsan sa iba't ibang posisyon, hindi natin na kung pare-parehas pa ba. Let's say, in weighting yourself, if you just step 1 foot on the scale, hindi naman ganun kabigat ang lalabas. Although in the second one. Then, pagka inano nyo, dalawang paa nyo, ganun. Or maybe, sa iba't ibang posisyon, kaya sabi, kung sa gilid kayo tumapak, malamang kakaiba yun. Alright? Next, measuring your height is affected by minor postures changes. Kasi alam mo, kung magsusukat ng height, kung ang tayo mo nakapaukot or parang kuba, ganon, hindi natin madedetermine yung absolute measurement ng height mo. Kundi ako nagkakamali. Kundi mali ang pagkakasukat. Hindi ba? Ganon ang ibig sabihin ng random error dito sa example 2. Next, when taking a volume reading in a class, you may read the value from a different angle each time. Alright? So, because random error always occurs and cannot be predicted, ito ba nape-predict natin kung ano ang sukat natin? Hindi. Ito, nape-predict ba natin? Hindi. Ito, hindi din. It is important to take multiple data points and average to get a sense of the amount of variation and estimate the true value. Next, systematic error. It can often be avoided by calibrating equipment, but it left uncorrected can lead to measurements far from the true value. Systematic error is predictable and either constant or else proportional to the measurement. Systematic error primarily influences a measurement's accuracy. Typically, causes of systematic error includes observational error, imperfect instrument calibration, and environmental interference. Examples of systematic error: forgetting to tare or zero balance produces mass measurements that are always off by the same amount. An error caused by not setting an instrument to zero prior, it is used to code an offset error. Ito, makikita nyo, predictable na siya. If you don't have balance, mayroon siyang possibility na alam niyo na kung ano. Next, measured distance is different using a new cloth measuring tape versus an older stage one. Proportional error of this types are called scaled factor errors. So, aside from examples, meron tayong iba't ibang error under systematic error. First one is offset. Second one is scale factor errors. Alright? Kasi dito, halimbawa, new cloth measuring tape. Yung bago, kung ano yung tawag dito, depends on using a tape. Maaaring may magkamali sa dalawang tape na gagamitin. Diba? That is already predictable. Drift occurs when a successive readings become consistently lower or higher over time. Electronic equipment tends to be susceptible to drift. Many other instruments are affected by usually positive drift as the device warms up. Once its cause is undefined, systematic error may be reduced to an extent. Systematic error can be minimized by routinely calibrating equipment using controls in experiments, warming up instruments prior to take readings, and compare values against standards. While random errors can be minimized by increasing sample size and averaging data, it's harder to compensate for systematic error. The best way to avoid systematic error is to be familiar with the limitation of instrument and experience with their correct use. Systematic error is avoidable, the opposite of random. Balikan natin yung definition. Balikan po natin yung definition. Ayan. Is predictable. And typically causes include observational error, imperfect instrument calibration, and environmental interference. Kung di tayo kulang sa instruments, we can avoid systematic error. Diba? If we have complete experience with the correct use of the instrument, we can avoid systematic error. Systematic error is avoidable in others. And while random is unavoidable. So, random error versus systematic error. Let us compare the one. So, taking reading value in a class from different angles. While systematic error, reading volume measurement before eye level from a glass tube will be consistently low value. In random error, measuring length with a metal ruler at a hot temperature. While systematic error, measuring mason and analytical balance with varying air currents. Random error has multiple readings of wind velocity on different height, time, gust, and direction. Next, while systematic error, improperly calibrated thermometer given inaccurate readings on lower temperature. So, what possibly we learn about that? The two main types of measurement error are random error and systematic error. Random error causes one measurement to differ slightly from the next. It comes from unpredictable changes during an experiment. Systematic error always affects measurements at the same amount or by the same proportion, provided that a reading is taken the same way each time. It is predictable. Random errors cannot be eliminated from an experiment, but most systematic errors may be reduced. So, well done. So, pagsimula na tayo ng ating lesson 1. Wala pa siyang computation kung napapansin mo. More on tayo, experimental and observational. So, next video, magkakaroon tayo ng conversion of measurement. I hope you still remember the length, the conversion of length, mass, volume, and etc. So, kasi yun ang lesson natin sa lesson 2, this in physics. So, that's all for today. Thanks for watching. See you in my next video.